But that said, let's crack on. So before we learn machine learning, I would like to recap on our data world, right, which is closely related to what Rita asked today in terms of how long things can take and how long depends on where the data actually originates from. So imagine, as I told in the beginning of this course, I said data, the role of a data analyst varies considerably, especially in this current world and current situation of technology and a booming, I would say booming job market. Why do I say booming? There are a lot of people looking for jobs. A lot of people now, there are resources available. So a lot of people have access to knowledge, right? Back in the days, a data analyst was maybe someone who went to school and had a degree in data analysis. But now, similar to you guys, you come 11 weeks, you have the knowledge you need to perform things that people actually have degrees for, right? It's similar in any other field, data science. There are courses out there. Some people have become remarkable data scientists by not having a degree. I went and did a master's, did a PhD. Some people have not actually gone through that route and they're still doing marvelous things in the world because of access to information. And so that makes the role of data, the role of a data analyst more comprehensive than ever before, right? So before, a data analyst would sit, receive data and clean the data, transform the data. So you see the pipeline here where the data analyst clean the data, transform the data, and do statistical analysis and visualization, right? Similar to everything we have learned so far, that is what a data analyst would do. So to get data from the database or from different sources, it can be an Excel file just given to the analyst, or the analyst may be required to actually query a database, which is what we learned at the beginning of this course. The data can come in different formats, structured, unstructured, and obviously we are mostly focused in this course with structured data. But in the beginning, I also mentioned unstructured data. Even if you get text or you get any unstructured data, in order for you to visualize or analyze the data, you need to transform this unstructured data to a structured data format, right? And we learned that in our introductory course, what it means to transform unstructured data to structured data. But if you can see the red arrow, that is basically what a data analyst role is. It's all about collecting data from a data store, which maybe have been already processed by a data engineer or may not have been processed. Sometimes in companies, they'll require you to do this processing. But when you get the data, your main task is to clean the data, transform the data in a format that you can visualize and answer business questions. What we have been doing for the past 1 month, which is transforming the data, visualizing the data to answer business questions or to develop hypotheses and answer those hypotheses. However, as I said, the job market is booming. So now some companies require data analysts to have a basic knowledge of machine learning or AI, because we are currently in an era of AI and machine learning. So can you create simple predictive models, or can you create forecasting models or simple AI models to take the data further from what we call descriptive analytics, which is the visualization, to more of what we call predictive analytics, where you can build a model to predict an outcome, or you can build a model to forecast into the nearest future. Companies that deal with costing, they will require maybe the data analyst to be able to build a forecasting model where they can forecast costs or forecast prices and so on and so forth. Or companies that require, maybe in a university, maybe performance. You may want to be able to predict a model where you can predict the performance of students even before exams are made, so that students that have low predictions, they can have more interventions because the school is required to have good performance. So it's a requirement here. When people fail, it's a problem. Even regulators come to your school, and you have more trouble when you fail people than when you pass people in developed economists. So this is the data world. We have data engineers that collect this data from different sources, structure it, and store them in what we call databases. You have data analysts that collect this data from the database or collect it from different sources, an Excel file, CSV file, or scraping the internet, collect this data, clean the data, transform the data, make insights out of the data. And you have machine learning specialists who actually do a lot of predictions and a lot of forecasting. And both the visualization, the prediction, the forecasting, you can call them data scientists to a certain extent. Obviously, AI or data scientists can go beyond this with more complex AI, things like LLMs, which is large language modeling, computer vision, and we will learn all of this in our lesson. So just to recap on this, what our course, our machine learning course, you will learn a lot about what machine learning is. You learn the importance, you learn the types of machine learning, you will learn the pipeline, how to create a machine learning model. So there is a certain pipeline similar to our data cleaning pipeline. You remember I always give a pipeline. Because why is a pipeline important? Because you know the steps, you know what to do next. So if you do this, you know what to expect to do next. And if you do this, you know what to expect. So pipelines are very important. So you learn, I'll, I'll introduce a new pipeline called the machine learning pipeline, which are the steps you need to take in order to develop and test your machine learning model. You learn the key aspects of evaluating your machine learning model, which is called overfitting and underfitting, which are the key aspects of evaluating your machine learning model. And we will build machine learning models to answer business questions in our different data sets. Again, all of this is the purpose is to answer business questions, right? So we'll build machine learning models that can help us to answer some of our business questions. So again, you gain an understanding of what machine learning is. You classify real world problems. You learn how to identify when a business question, what task is required, what machine learning model is required to solve different business questions. And you learn how to evaluate the performance of a machine learning model. You learn how to improve the performance, and you learn how to write Python to do all of this as well. So again, let's relax. It's a new concept, but it's a very interesting one, especially when you get the concepts right and when you build your business questions relating to AI and you start putting the pieces together, it becomes very interesting. So what is AI? So if you have noticed, I'm talking about machine learning and I'm talking about AI. And the main reason why I keep talking, sometimes I interchange machine learning for AI, is because machine learning is a branch of AI. AI is it's all everything you learn from ChatGPT to weather forecast to customer segmentation to predicting prices to the stock exchange. All of these are different branches of AI. So AI is extremely broad, extremely broad. Machine learning is just a small piece of AI, and that is what we'll be doing in this course. We'll be learning machine learning, which is a small piece of AI because AI is extremely broad and you cannot be an expert in all the branches of AI. So when you look at the branches of AI, people go for PhDs to learn a specific branch of AI, right? So in my PhD, I went and learned things like machine learning, computer vision, and other branches. There are some people I had colleagues that are more proficient in generative AI. I had colleagues that were more proficient in speech recognition kind of AI. So it's different, it's broad, and you cannot be an expert in everything. And that's why I've chosen machine learning, which has to do with data, because there are other aspects of AI which require no data, but you still build an AI algorithm. So what is AI? So AI is creating computer programs to perform tasks typically requiring human intelligence. That is my definition of AI. Obviously, you go out there, there will be 2 million definitions of AI, but the most simple definition I have come up with, which can perfectly define AI, is creating computer programs to perform tasks typically requiring human intelligence. What is a typical example? ChatGTP. Before you get a document, you give a human to summarize that document for you. You say, can you give me, your boss will come and say, can you write a long report, and your boss will tell you, I don't have time. Can you just summarize? Tell me, briefly summarize the report and tell me the key things in the report. And that requires human intelligence, right? You need to have read the document, understood the document to be able to summarize the document. It requires human intelligence. But now you can get that document and give it to a machine, to a computer program. That computer program will perform that task for you. That computer program will take that document and summarize it and tell you, oh, this document means this, that. So anything that does not require human intelligence is for me, it's not AI. So AI is anything you have replaced human intelligence with a machine. So anything that a human required some form of reasoning or reflection to do that task, and which has now been replaced with a machine, for me, I consider it AI. Another good example is fraud, right? Before in banks, they will take bank transactions, they'll look at bank transactions, use their intelligence, use their expert knowledge of what it means by a fraudulent transaction, and they'll flag this transaction as fraudulent or flag this one as not fraudulent, and so on. But now we have AI algorithms that run in the background. When you are performing a transaction, it just runs, it takes your transaction, checks it using all its knowledge it has, which has been given. That knowledge obviously has been given by the programmer or by the data or whatever, and it checks and it tells you, oh, that's why sometimes a transaction will bounce, right? You do a transaction, it'll tell you, sorry, the transaction did not go through. Can you confirm if it's fraudulent or not fraudulent? Or there'll be another stage of verification where they'll ask you for your PIN, or just to understand if it's actually you. That is human intelligence and has been replaced by a computer program. So I've given some few examples. Customer segmentation. Before, to understand your customers, to understand who is a loyal or a disloyal customer, you need to do a lot of reasoning behind. You say, okay, this customer bought 6 bags of oil and he has bought it consistently for the past 4 months, so I call him a loyal customer. This is a customer, even though he bought 6 bags of oil, but he comes once. That is human reasoning. We are thinking about the solution. We're thinking about rules to define the customer, but now it's replaced by computer. You pass your data, your computer tells you this is a loyal customer, this is a disloyal customer. Make predictions. Weather forecast, one of the most remarkable. We use it every day, especially us in the UK with a very unpredictable weather. We use our weather for before we leave our house. We need rain, we need snow, and it's not 100% accurate, but to a certain extent, 70% accurate. You get the right predictions. And that was something that was done by humans. It was even something that humans could not even do, right? It was even above human intelligence, because we could not actually forecast what will happen tomorrow. But humans could actually look at the patterns of what has happened in past years and think about maybe. So that's why people will tell you it will most likely snow in December, because past years it snows in December. But now a machine can get that more accurate and even tell you a particular day that it will snow and a particular day it would snow and not snow. Provide answers to questions, summarize questions. ChatGPT's own is large language modeling, which obviously ChatGPT is an umbrella behind this. There are so many different large language models. You have Gemini for Google, you have ChatGPT for Microsoft, and there are many others, and all of them run behind what we call large language models. And this has been remarkable as well. This is what has even made people to be aware. I remember back in the days when I came after my PhD, I told my dad I had a PhD in artificial intelligence. My dad was like, what is artificial intelligence? What does that mean? I don't understand. And 3 or 5 years after my dad heard about ChatGPT, I sent him a link to ChatGPT, and he was able to ask a question about his business, and ChatGPT gave him like remarkable business questions and business that he has never seen before. And he was like, and I told him, okay, that is artificial intelligence. That is what I went to school to study. So ChatGPT has changed the ball, right? And now we have machines that do remarkable things. Even us, the artificial intelligence engineers, are using it to answer questions that we did not think possible. You have seen in my coding, I sometimes when ChatGPT doesn't work when I'm coding, I shiver because I'm now so dependent on it that it's remarkable. Yeah, right. You have speech to text. ChatGPT and a lot of the large language models do this. You talk and they change subtitle, right? When you're talking, you see the subtitle changing it to um, text, and we have the reverse where you can give text and you have a voiceover generated by an AI model, right? You say you give it a whole text and it will generate the voiceover. People use that a lot in marketing. We have generative modeling, where in a lot of science there is limited data and people are creating new data points from old data to mimic the old data but to create new ideas, which is quite remarkable, right? So we have generative modeling. So these are just few examples of AI. We can keep going and going. It is here to stay. We have our self-driving cars, Tesla cars. We have robots now that deliver, Amazon robots in the US that deliver products to people to their doorstep. We have Amazon shops where you shop without seeing a teller and you just go out and your account is debited or credited. It is remarkable and it's here to stay and it's here to become more complex, and that is why we are learning the basics and the fundamentals, because even now sometimes you don't even need to develop AI algorithms. You just need to understand how the algorithms work, and there are a lot of tools out there, ChatGPT, a lot of tools out there that you can just use to do the AI task for you without actually developing the model. But the whole reason why we are learning is in case you want to implement, make it more specific to your business. You understand how you can tailor it to your business. In case you are you are looking for employment and you are going to a company that they actually want to develop an in-house algorithm. They don't want to use ChatGPT, which is publicly available. They want to develop in-house. You understand the fundamentals of AI so that you can be able to assist in the development of AI algorithms. So that is AI. So why is AI important? Obviously, even the definition of AI tells you it's important. It's tasks typically require human intelligence. So we want to release the burden for human intelligence. We want to release the burden for human error. Remember, humans are controlled by things. We get tired. External factors influence emotions, but machines do not have emotions. They do not get tired. So we are just trying to eliminate a lot of human tasks which will require things like human repetition, so automate repetitive tasks. So imagine every day there was someone in one tunnel. Many years ago, we had a weather forecast department, maybe in the UK or whatever country, that their work is just to use their intelligence to tell the country that, hey, maybe today it will rain. And now that repetitive task of doing that thing, now a machine just does it and tells us every day the weather forecast of what will happen every day, and he has automated that repetitive task, and now humans can be deployed for other important tasks which we require humans. It enhances precision. Remember, humans are bound to error, so a human can do its calculation and make an error, but machines are machines. They use CPUs, they use things. So when a machine cannot use, you cannot be subjective. It's what you have programmed that machine to do. If you tell that machine that open that door at 5 a.m., a machine will just go open the door at 5 a.m. They are bound to precision. So it enhances precision. And because we have data of historical data, of massive historical data of things that have been happening in the past, we can now use that historical data to design or to enhance the accuracy of what we currently have. Because imagine we have data, fraudulent data of, since fraud did not start today, fraud started about 30, 50 years ago. Why do you want to enable a human to still go through that stress of trying to understand why it is fraudulent when a machine with its accuracy, with its precision, with its CPUs and everything can get you that more accurate model that will tell you the reason why this is a fraudulent transaction and actually more precisely identify a fraudulent transaction better than a human. So computers are more precise than humans. Definitely, there is a big area of AI now called responsible AI and what we call explainable AI. And because regulators, when AI came, there were no rules, there were no laws to govern AI because AI was technology goes faster than law. It has always been, right? That's why technology laws are we keep the lawyers and the legal personnel or specialists keep trying they keep trying to go back to different technologies and create laws for technologies, right? They'll go back to self-driving cars and ban self-driving cars in certain cities because obviously they have seen, okay, one self-driving car had an accident and they'll say, okay, we'll ban self-driving cars and go back and revise the laws regarding self-driving cars. But unfortunately, the truth is more driven cars, human driven cars are having more accidents than self-driving cars. The statistics are there, right? But the law, because these are AI and machines making decisions, the law needs accountability. Who is accountable for the errors which are made in self-driving cars? Is it Elon Musk? Is it the programmer? It's not Elon Musk that wrote the program. Is it the programmer himself, or is it the owner of the business? Or is it the data where they collected the we hold the data liable, right? Is it the data where that was used to develop the algorithm? Who is actually liable in these cases of error? So there is now a big shift from AI to make decisions to AI to support decisions. And so instead of using AI to actually just make decisions, you use AI and you have that human level layer where the human now takes the decision made by the AI to make further a human decision rather than an AI decision, right? So you take decision because the AI will give you a decision with a lot of other parameters. It will tell you, this is my decision I've made, this is my reason why I've made the decision, and the human will take it and say, does this make sense? Has the AI covered all the aspects? If it has covered, then I make my decision. So it becomes a supporting tool. And my research has always been on responsible and explainable AI. So I'm a big fan of AI supporting decision making rather than AI making the decisions. So again, it's to handle complex tasks, right? We have spoken about things like weather forecast. We're talking about fraud. To identify fraud is really difficult. But now we have AI algorithms that, to a certain extent, can tell you that if a transaction is fraudulent or not, and it can adapt when more knowledge comes into play, right? When we get more knowledge about these transactions, that AI algorithm can actually adapt and learn better what is a fraudulent transaction. Its greatest use now in the world is for innovation and discovery. Yeah, AI is being used in medicine, in healthcare, in manufacturing to develop new drugs, to develop new algorithms. It has a lot of potential. And why is it that AI can discover or be more innovative than humans when it's humans that develop the AI? It's a very big concept, right? The good thing about AI, which is different from a lot of things or different from the past, is that before AI was rule based. So a human would develop a rule base. We say, if it rains today, then do this particular action. So it was very rule based, which was still very dependent on the people who developed the AI. Now, AI is still relies on optimization algorithms. What does optimization algorithms mean? It means we give AI, or a lot of the algorithms that actually use data, we give it the data, we create an optimization algorithm. An optimization algorithm is an algorithm that will search deep into that data to get the best possible solution. It requires large CPUs, large GPUs, powerful machines, and that's why you see countries like India, America investing in data centers, in powerful GPUs, state-of-the-art machines, because sometimes for innovation and discovery, you just need to keep your laptop, you just give like massive amount of data, write the algorithms, leave the algorithms with the laptop for 3 days, 5 days, sometimes even months, and the algorithm is optimizing itself. It's searching for the best possible solution using all its GPUs, all its memory, all its computing power to get the best possible solution. You can imagine how long it will take a human to be that powerful, right? We have time, we are tired. You cannot sit 5 days and you're thinking about a solution. No, 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 no. So that is the power of AI. It's powerful for innovation because we're giving it GPUs, we are giving it computational power, we are leaving it to explore. So it can explore all sorts of solutions, and it can discover a solution that has never been thought of by a human. And that is the power of AI. And that's why AI is important in our day-to-day life. And it will be important for the next century or the next decade. So century is more than decade. So the next century. So so that said, before I will stop there again, just to conclude, responsible AI is what I've just to summarize. We want to, it's a very, I added this slide because I'm an advocate for responsible AI, because AI, we are becoming reliant on AI, right? So a lot of people now cannot even write a sentence or cannot even write an email anymore, right? Everybody uses ChatGPT to write an email, uses ChatGPT to write a sentence and comment. So we are now becoming reliant on AI. So when we become so reliant on AI, we need to trust that the AI is giving us the required or accurate, fair, transparent results. So that is where responsible AI comes into play. So responsible AI is AI that takes consideration the entire AI pipeline from development to deployment to interpretability. So how do we develop the AI? Us, the programmers, do we use the right principles and frameworks to ensure that the AI is fair, not biased towards a certain particular class of people or certain demographics? It's fair, it's transparent, it's reliable. Can we rely on this AI? To the deployment, when we deploy it, the incoming data which is used with that AI, is it a replicate, or is it similar to the data that was trained? Remember, AI or machine learning, for example, is trained on past data. And that past data has some certain characteristics where even the new coming data which you want to use to predict an outcome still needs to have similar characteristics with the past data so that you can use your model, right? So for example, if I take my data and I train it on Africans, their purchasing behavior, this AI model is 90% or 100% accurate. And I take this model and I use it in China to predict the purchasing behavior of Chinese. And I'm using that decision to make, I'm using the outcome of my model to make informed decisions and policies in China. You can imagine the issues that I am actually the issues with that model, right? Because the model, the characteristics of people the purchasing behavior of Chinese will be totally different from Africans. So there's the model was developed perfect. It had a 100% accuracy. But now the domain or where I have deployed this model, it has a totally different behavior from the environment I trained the model. And how do I use the model? The usage of the model is one of the most important. As I said, I support AI for supporting this as a supporting tool rather than a decision-making tool, right? That's why even the banks, when they reject your you are a fraudulent transaction, they don't just reject it. They'll still give you that liberty to be able to ask, to be able to confirm if it's actually fraudulent. So it becomes a supporting tool rather than a decision-making tool. So when we're talking about responsible AI, we're talking about fairness. The AI system should be designed and trained to avoid bias and discrimination. There are many other aspects of fairness. Transparency. It should operate, it should be transparent in the way it operates and makes decisions. People are supposed to understand. A lot of people are using ChatGPT, they don't understand what ChatGPT, the fundamentals of how ChatGPT was developed. And that's why some people use ChatGPT and they get bad results, and they are so worried and they criticize ChatGPT, they criticize the large language models. But you need to understand, ChatGPT was trained on available data online, Stack Overflow data, Google data on websites, data on news outlets. So if you take ChatGPT, you cannot use ChatGPT to make an informed decision on legal issues in your company, because ChatGPT is not aware of your company's data. So that is where you need to take ChatGPT, retrain ChatGPT on your specific data. So if you are a company that is dealing with legal documents, ChatGPT obviously has seen some legal documents, but those are documents that were exposed to ChatGPT maybe online. But if you go now to your very specific legal documents, so if you are specialized in, let's say, family law, and ChatGPT has not seen enough family law data, you can take that ChatGPT model. That's why the model itself is public. It's available for anyone to use. You take the ChatGPT model, you retrain that model on your particular family law data set, and you are now sure that that data can be used now for your own business. So the way we use the data, the transparent, you need to understand how the model operates and the decisions that are made for the data. Accountability. There must be clear protocols to determine liability. Yes, so you develop an AI model. What happens if that AI model goes wrong? Self-driving cars, robots. If it goes wrong, what happens? Yes, I know a lot of colleagues that are doing AI and robotics, how AI influences law and robotics, or law and AI, how AI influences robots, how AI influences things like smart contracts, how AI influences self-driving cars, the law between AI and all of these things are very important. People need to be liable for something if things go wrong. Privacy and data protection, right? Very important. You need to protect individuals' data. You cannot build an AI system where they can have data leak, where someone can use your data to extract the data that was built with your AI model. It happens, right? People take people's AI models now and are able to extract some key aspects of the data that was used to develop the AI model, which is quite remarkable to be able to do that, but it happens, right? Reliability. We rely, as I said, a lot of people are now reliant on AI. So the people who are developing the AI model need to ensure that the AI models go through rigorous testing and validation, because the people using the model rely and are confident in the data. So you need to ensure you test the data, and you will learn this in this course. You will learn how to rigorously test your data and validate your data before using your data, which is a key aspect of this course. Human control and autonomy. Humans should maintain some control over critical decisions. In airplanes, you cannot use airlines AI totally in critical conditions like healthcare and transportation. There's some form of human in the loop, right? Humans should still maintain some form of control and oversee the decisions made by the AI solutions. And that leads us to what I always say, stakeholder supported AI. When you are developing an AI system, you need to ensure that you bring on board all possible stakeholders, from the decision makers to the users, to the developers, to the researchers. Everybody must be involved in that decision making, in developing the AI solution. So I am a very big fan of stakeholder. In fact, my PhD thesis was on stakeholder supported AI. So everyone must have a say, must participate in developing the AI solution. So we need to look for solutions where we can embed knowledge from all possible stakeholders of the AI solution, from the managers to the users to the developers. So that said, we will end our lecture today on responsible AI. And next week, we will talk about the branches of AI. And you see at the top is machine learning, which is what our course will focus on. But there are other branches. We have deep learning, we have computer vision, natural language processing, which is chat GTP kind of system. We have expert systems, we have reinforcement learning, and we have optimization, which most of these systems still fall under the umbrella of optimization, because as I said, you are optimizing your model to get the best possible solution from your data or from your problem.